Okay, this is our confocal microscope, LSM 880. So if you are the first user of the day when you come in, if the computer isn't on, you turn it on, you set it as you need. This is the control for the microscope. If it's not on, then you would turn on the switch here and turn it on. Okay. This is our microscope. The optics are covered right here. Occasionally there's also a cover. So if you come in, it may be covered. So we just took it off here. Right. And these are our microscopes here. All right. Okay. The microscope is on. The computer's on. Sometimes we want to restart the computer before we turn on the machine, just to make sure everything's in sync. Okay. First thing we need to turn on is the Zen Black software. You can find it here, or you can also search for it in the program. All right, so I'll turn on the Zen Black program here. Okay. Then you would click on Start System. You can also click here if you're interested in what's actually booting up. Okay. So you can see the taskbar, and it's just loading all the interfaces that you have. Okay, so then you'll see this interface here. Right now it has a 10x active. We're on the locate screen here. First thing I would recommend is you turn on the laser. So we'll double click on acquisition tab, and then we'll see these screens here. The Argon laser, if you're planning to use these laser links, 458, 488, or 514, then you'd need to turn on the Argon laser. This usually takes a while to turn on. Let me click on laser properties here, and it's gonna wait. So this usually takes about 5 minutes for the Argon laser to power up. All the other 405, 541, and 633, they could be turned on and off anytime, so they don't take a while to turn on at all. Only the Argon laser takes a while. You'll notice this is the Argon. This is where it's going to power. You're going to hear this machine here make some noise. So it's just warming up and getting the Argon laser ready. And these are just the typical settings here. All the red tape you see is just, it's all the switches that are on, and I'm just leaving them on. When you turn on the microscope, you don't have to touch any of those switches. You just need to turn on the power switch here. All right. So then over here now that it's warming up here, it's saying this is about how long, 270 seconds for the Argon laser to be powered on. While that's happening, we go back to locate, double click over here. Okay. We could load our sample onto the microscope. So here I have a biological sample here. Most of the samples is ideally it's on a microscope slide and with a sealed cover slip. Okay, so we have that there. I'm gonna lower the stage a bit. These are one of the demo samples. It's completely sealed. So here, if you're using a biological sample or something freshly made, you'd make sure to wear the appropriate PPE. So I'm going to lower the stage a little bit more. I'm going to use the stage control here to move the stage out. Okay. Alright. So then we just slide the slide under. Just right on the edge there. Okay. All right, I'm going to use the control here to move the stage back. All right above the 10x here. So how the stage selector works is, this is the 10x, this is the 20x water immersion lens, this is the 40x, and then this is the 63. The water immersion lens, you'd have to add a water droplet on it and then view it. The other ones require a special oil. We'll mainly work with the 10x, and if we use the 40x, then we use the glycerin here. If we use the 63, then we're going to use the Merced 518F. So once you select, so we'll start off with the 10x. So you see how the 4 aligns with here, and we move this down here and move it all the way down, and it locks in place. Okay. And then we just need to move the stage up. There. Okay. And the reason these sets are here, if you go over here, these are just the presets. So right now it's the 10x here. If we change the torrent, these should change accordingly. Okay. So in the locate tab, we'll need to turn on the light. So I'll hit this light bulb here. I'll hit on, give some illumination to the beam. Sometimes for some reason for this instrument, when we click on, sometimes it turns on and then it turns off right away. So sometimes we have to double click. Okay. All right. So over here, the microscope light should be on. If you need to increase the light more, you can also increase it here. And if I increase, as I turn the knob, you'll see it increase as the slider goes up as well. Okay. So we'll go over here. We're trying to, you have to look into the eyepiece and locate where the sample is. Try to increase. So I'm just using the coarse knob here. Now I'm gonna have to reposition the stage, make sure it's actually on the sample. Okay, so it's there. Okay, and then let's see if we can actually see him here. Okay, probably can't see that better. Okay. But you can look through there. So I focused it. Okay, we'll switch back over here, turn off the lights. Something to note, this is to open the shutter here. If you close this, you won't see anything, so make sure this is open when you're actually viewing this. Okay, so let's just go back to acquisition. So up here, I'll double click. Okay, by now you can see the Argon laser is backly on, and over here you can see it's ready. Okay. This biological plant tissue I have here has some fluorescence for typical blue, red, and green. Okay, so what I'm going to do is, first off, I'm going to, let's lower this here first. Okay, I'm going to start by viewing bright field mode so I kind of see what we have here. So over here, I'm going to go down, click here, increase the gain here, increase the max. Okay, and I'll hit live here. So we sit live there. Increase the gain here. Alright. Turn on this laser here. Okay, so I'm adding one laser light here. This is, and then I'm giving illumination from here to here. I'm doing a max pinhole because we're trying to just view it in bright field. We could increase the gain here, just see that. So then we kind of this is what we kind of see when we look through the optics. So this is if you want to see a visual. So we have the focus, coarse, and fine here. We could also adjust the coarse and fine on this controller here. So, all right, I'm gonna focus, see if the image looks better. All right, so you can see better or worse. Okay. Okay. And we can always optimize this as we wish. So, what I'm gonna do is set the exposure here. All right, so this automatically sets the exposure for the gain here, for these values right here. And hopefully we'll see a better image over here. All right. Hit live. I'll lower the gain here, make sure it's not as bright. You can also increase the laser power here. Lower the 3 units. Okay, but this is just to help you visualize it. All right, and then if we want to, so this is just for bright field. If you kind of just want to locate where it's at, if it's hard to look for it. And then we could also check the fluorescence. So I'll go over here. You could do a smart setup or a new setup. We also could load parameters. So we could load different parameters here: 4-channel, 3-channel. 3-channel sequential gives you the basic red, green, blue. Okay. If you want to make your own, you could go to, I recommend doing smart setup. You'll get this window over here. You could pick whichever dyes that you have. The most common ones are usually over here. You can type in, say, Dappy. Change the color. Typical Dappy is blue. Hexaflora. Rhodamine G or something. So you can pick whichever elements, as long as it's tabulated, and have it there. Hit apply here. So there's like the best signal set up where it'll take longer, but you'll get separate signal. Or there's the fastest, where this tries to get as most speed, but there may be some overlap of the data. You may not get as much signal as you wish. As you can see here, this gives you separate. This breaks it up a little more. So it depends on what kind of settings you want there. Okay. I'm gonna hit apply here. So once you have that, you have all these different tracks. Click here. You could adjust the range of how much you want to collect from the emission. You could adjust the excitation for the specific laser there. Okay. If you one thing to note is when you adjust this, it does affect the other spectrums. So you can see how this red, if you move over here, the green gets affected, it gets slid back there. Okay. The pinhole here affects, since we're doing confocal, the smaller the pinhole, the smaller the thickness section. So these area units here represent how thick of a section we're viewing. So right now this is 12 right there. If I increase the pinhole, you get a thicker section, 30 micron section of information. Or you could always do one area unit, have it the smallest length, or you could do max, which basically operates almost like a wide field fluorescence machine. So okay, so that's there. Since I have a plant tissue sample, what I'm going to do is just use the typical 3-channel. Okay, so 3-channel, 488, happy. Okay. So let me kind of show you what we generally do. If you're unsure what kind of sample it is and you're not sure how to get the illumination, what I recommend is we'll deactivate the tracks here. We'll start with the color that, since this is a plant tissue, I'm pretty sure we'll see chlorophyll, so we'll see the green signal. So we'll start with the green. Clicking on the track makes it the most active track. Tells you which laser it's being active, and these are the settings for the gain and all this stuff here. So when we first start off, since we're able to focus it and know where the position is through the bright field, we also hit set exposure here. Okay. It's gonna do the automated set exposure plan to see what's the best green fluorescence for the sample here. Green signal there. There's also this histogram here. You want to hit best fit or min max. Right. There's different ways to do it there. Okay. So this is for the green. And then I could also do the same thing for the blue. Go over here and set the exposure again. So that's for the green. All right, I'll do the same thing for the red. I like doing it individually so it doesn't have to do all the channels at once. So now we have the red. Set the exposure here. Okay, so that's the red signal on there. All right, and then sometimes the fluorescence focus is a little different from how we perceive when we look at it. So I'm gonna go click on autofocus to see where the focus for the fluorescence is for the red signal here. So this is like the Z height of the sample, and then just seeing where where it'll find where you get the brightest red signal. Right, and that'll be where your new focus will be. Okay, that's for the red. So I could turn on the tracks again over here. Okay, now we have all 3 colors. I'll hit live. Live is just view it regularly. So it's going to scan all 3 colors, so you can see that. You can also do split right here to separate the channels, see all 3 individual colors separately, or move it together. If you like what you see, you could go over here to snap. Take a picture. All right, once you have that, you could save it. File, save as. Okay. I'm gonna save this on the desktop. Desktop, we'll go to the D drive shortcut here. I'll go to the user here, and I'll just temporarily save this for now. Right. Image 2. Okay, so that's for the basic imaging there. We can probably make this picture a little bit better. All right, so the settings here, if you wanted more red signal, you could adjust this here. You could do the same thing for the green, same thing for the blue. Okay. This here. It looks pretty pixelated here. So what we can also do is increase the number of pixels here. So I could start off with 1,000 by 1,000. Right, and this is the scan speed. So if it takes longer, we'll lower the number. It will take longer, so you get more signal. Or you can make it faster and you get less signal. But since we want to improve the picture, we'll decrease it here. This is averaging, so how many scans you want to do. It's going to take an average. So we can go here. You can see you go up to 16. So the longer you make it, the longer it'll take. Right now we'll just do 1, just so you can see how it is. Hit snap here. You see how the image has improved. Let's see the individuals there. Okay. So this was just from increasing the pixels from 512 by 512 to 1000 to 1024 by 1024. Okay, so this compared to the old image. So this was 512 by 512, and then this was the new one. Right. Let me show you a trick here. So one of the most useful tricks that you could do is, so we save these pictures. So this one, let me save this picture as well. I'll just click here, save. Let's go. So this is image 3. Let's save. One of the neat tricks we could do is when we switch between image 2 and image 3, if we want to know what parameters we used, right? So we can see how this one here, image 2 is, so these are the current settings here, but when we switch back to 2, if we want to load the parameters for this, we'll go over here, hit reuse on the picture. And then up here, it'll reload the picture, so we knew it was at 512 for that picture. And then we go back to image 3. All right, let's go hit reuse. So this is what the current settings are for the last image we took. We'll hit reuse. And now we see that it's 1000 by 1000. Okay. The software video also covers this, but I just wanted to show how this works here. We can always optimize the image by adjusting these parameters here. Okay. Another useful tool is using the crop feature down here. So we want to artificially zoom anywhere, we can hit crop. All right, say this area of interest, we want to zoom in this area here. Maybe on the side. And it shrinks there. So we want to zoom in, artificially zoom into this location. You'll see the scan area kind of changed. So how we move the square here kind of affects where that box is moving. Okay, so I move this here. All right, so we'll just zoom into this location here. I'll hit live. All right. And then we'll zoom into this location. All right. We could optimize this. We could reset the exposures for each of the colors if we wish to again. All right. We could adjust these parameters here. All right, so it looks like if we ever run any of the samples and it looks like it's too bright, we could or see that we think that it's overexposed, we could always use the range indicator. So first off, let me hit split here. So we see the 3 different colors. We go down here where it says range indicator. I'll click there. Okay. So where it's red, that shows it's overexposed. So there's too much signal from the photo multiplier, and we could reduce that. So it looks like this signal here is overexposed, some red here too as well. So I could reset the exposure for each of these so they don't appear as bright. Okay. I can either reset the exposure or I could also manually adjust them. So let me go back over here. I'll hit range indicator. All right, so let's work with this green here. So I'm gonna click on a green track. All right, with the green track here active, I'm gonna reduce the gain here. And as I reduce the gain, you see it becomes more grayscale. So if I increase the gain, it gets a little more overexposed. Decrease, it's more grayscale there. Right. You can do that manually if you want to, or you can also let's turn off the live here. All right. I'm just gonna adjust these manually. set the exposure. So you can see how you artificially zooming in and adjusting the exposure, you can kind of see a little better picture here. But we're still at 10x here. So up here, you could count it as we're zooming in by 6.7 times 10. That's like a 67, 67x kind of view. Okay. All right, I'm gonna check the range indicator. Right, you can see there's still some red, but most of it's gray now, so that should be a little bit better. You can manually adjust it if you wish to get rid of the red. There. We can also do the same thing for red. Set exposure. There we go. Turn on the red. The blue is not really much, so I'll just have the red and green on. Hit live. Let's put the image here. So you see these images there. I'm gonna focus it. So adjust the height. See, we could find a region where the red pops up more. So you can see this red object here. So what I could also do, so right now, you see how you key different sections of this red object here, and you see it changing there. This is all based on the area unit here, so it's only a 5.7 micron section. So if the objects inside are bigger than that, you always increase the pinhole. So say if I wanted to see 10 micron section worth of material, so I would adjust that and then refocus here. So then this is for that section there. Okay, so then you can see this a little bit better. We could also, so right now the image may not look, the quality may not be as good. You can also increase the let me show you here. So this one does a sum if you want more signal, but since we noticed that we don't really want more signal, what we want is averaging the signal, so we'll scan it twice, get the average to reduce any noise. We'll also slow down the scan a bit just to get more, try to get a better picture. Okay, and then we'll hit snap up here. As you notice, when we scan a little bit slower, you get more details. We didn't see these individual features before, but now we see them. All right, so most of the time you could slow down the scan. You may help identify more features of interest. You may have to reset the exposure as well. Right. And then the taskbar down here predicts how long it will take for the picture. So, it's usually pretty accurate over here. So it says the scan time 1 minute and 20 seconds. So that's usually how long it's going to take based on where. Okay, so that's done. I'm going to save the picture. Image number 4. Okay. Just to make this picture look a little bit better, I'm just going to set the exposure. For a lot of the image taking, we'll have to just optimize these parameters over here as best you can. Set the exposure, try to get the best picture you could get. Right now, let me adjust the settings here, make it a little bit faster. Okay. Since we're just doing the exposure, so we don't have to take a full picture here. All right, let me check the range indicator down here. Okay, so everything's gray except for these red objects here. So as long as most of the picture is gray, only this area is overexposed. So. All right. If you're worried about that, you can also readjust it. So I'll hit live here. Click on the range indicator again. I'm gonna lower the gain here. See if I can get rid of the red without compromising the other signal in there. Right. So we still see the object. So then this is less red here. Okay. All right. Let me adjust for the green, set exposure. Okay. Green looks awfully bright, so I'm gonna go hit best fit here, hopefully, or we can hit reset and see it goes through the whole range. Okay, so you see the picture looks a little better. It doesn't look too overexposed. Okay, and I can double check that with the range indicator down here. Okay, blue indicates lack of signal, so and then gray is what we want here. So this should take a better picture here now that we have set these settings set. So nothing's overexposed. Okay, so we'll have these two signals again. All right, I'm gonna increase the mean to 2, so we'll have it there. Scan speed, hit snap. Okay, so this should be a better picture than before. Let's show split so we can see both. So here you can see the details are a lot better when the images aren't overexposed. You can see a grade a scale from too bright or lack of brightness. So you can see the individual smaller objects here as well now more clearly that we weren't able to see before. All right, so we'll just wait for the picture to take. Right, and then you could spend all day with just optimizing the pictures, and it'll just depend on what kind of samples you're looking at. Okay, and this is still just at 10x. Okay, so that's complete. I'll hit save. Here. Image 5. Okay, so we can compare them. This was image 4, it's overexposed. Let's see, let me go down to graphics here. Display. I'll reset this to see if that improves it a little bit. So it goes through the whole histogram signal. Let me just show you how the histogram works. You can also adjust it there. So this is how it was with the full scale for image 4. Things look slightly overexposed. This is for image 5, same histogram signal. You can see it's there. Versus that. Okay. So this is for the 10x. Let me show you how to work the water immersion lens. You just add a water droplet and you view the same thing. Let me go over the 63. The 63 and the 40x are pretty similar since we switched to that lens or that objective, and we just add an oil drop. So let me just go over that. So let's go. So let's go back to let's hit live first. What I like to do is reset the settings here so we know we're not zoomed in. We're looking at the whole object here. So, okay. So this is the whole picture here. When we fix the exposure for the red and the green here. So we can see all the chlorophyll. And we can also see all of the signals. So I'm just adjusting the focus here just to see if we can get more signal here. So, okay. I think we're at a good spot earlier. Okay, so you just kind of see. Okay. All right. Since we have this, what I'm gonna do is kind of, so when we switch to 63, it'll be hard to see where we're actually looking at. So I like to kind of center where we want. So if I'm interested in this red object over here, I'm going to center that in the middle of the screen. All right, oops. All right, I'm going to center what I'm interested in the middle. Alright, so about this area here, it should be the center. Okay, I'm gonna hit stop here. Alright, so what I'm gonna do now over on the microscope here, I'm just gonna look this up here. Alright, so if we were gonna use water, we'd go here, we add a drop of water, and then move it down here for the 20x. Alright. 60. For 40x, same thing. A 40x would use the glycerin. And then let's do the 63. Let's for the, here we have the immersal 118 here. So drop middle there. So we just need one drop. Try and make sure there's no air bubbles. And then just be sure when you're done using the oil that you also, we have lens paper, and we also have lens cleaning solution. So make sure you clean the objective and your microscope slide afterwards. So we have that. All right. When I switch between the 10x and the 63, I usually don't adjust the Z. I just center where I'm interested in. Switch to 63, move all the way down. Okay, and then I'll go back on the microscope here. All right, or we go to locate. All right, we see this is it's switched to 63 here. I'm not gonna look it through over here. I'm gonna go through acquisition here back again. Okay, I'm gonna hit live to see if we see anything. Okay, so we do see something. So in this, for the 63, we still see this region here. I'm going to use the joystick here to recenter this object here to the middle. Okay. So you can notice there's a difference between the 63 compared to the 10x already. You can see the image quality is already improved, and we haven't this is just in live, so the picture already looks good in live. All right, I'm gonna adjust the focus, see if I could get anything better. Maybe the focus is there. Okay, so I'll just get it there. You'll notice a little something over here. This is the Z, or the area unit space here for the pinhole. When you're in 63, the amount of signal you get is a lot smaller because it's the Z thickness is smaller. It's only 1.6 compared to what it was earlier. Okay. Sometimes what we have to do is probably have to reset the exposure for the 63. So I'm gonna reset the exposure for the green. Let me turn. I like doing it individually, so I'll turn off the red. Just do the green by itself first. Do set exposure again. You see the picture looks a little bit better. Okay, let me check the range indicator down here. Okay, so nothing's overexposed, that's good. Okay, let's do the same thing for the red. Set exposure up here again. All right, you can see more details are popping up. Okay, and you see the smaller specks and stuff like that. Okay, let me check the range indicator real quick. All right, so there's some red, but for the most part, everything is gray. So I could manually adjust this to get rid of this red if it bothers. So I'm gonna go hit live over here, make sure it's active. Go back to range indicator down here. Okay, and then go over to the gain master here. I'm gonna adjust it manually to reduce the red signal. Red means overexposed, gray means signal, blue means lack of signal. So that's good. Off there. Okay, so we'll turn back on both of these tracks here. I'll hit stop over here. Click on both these signals. Right, so then let's go over here. We'll do a mean of 2. Let's slow down the scan a little bit. Actually, let's do fine focus first. Let's see if, I tried to focus it earlier, but we'll see if the autofocus gives us a better focusing point. Let's see. Right, and also there's a bar down here. Shows you how long it'll take for it to figure out the autofocus. Okay, so once that's done, it takes a picture for you. Alright, I'm going to do the split as well as range indicator. Alright, so that doesn't look like anything's too overexposed. Everything's good. Okay, so I can also just save this. So you can see the difference. So this was the 63. Let me go back over here. Okay, so this was the 10x at 6.7 zoom. So it's about 60. This is like 67 artificial or digital zoom on the 10x, and this is what it looks like. Okay, and then this is 63 with no zoom, so this is 63x, and you see the details are a lot better. Okay. All right. So you see the reason why you'd switch to 63 with the oil to see better data. You can also zoom in when you're using the 63. So let me go over here. We'll hit live. Or sorry, we'll zoom with the crop feature here. So we already took a picture here. We'll hit crop. All right, let's zoom into some region of interest. Let's zoom into this smaller section over here. See if we can see any details there. Okay. All right. I'm gonna hit live. All right, so it zooms into the section here. Okay, I'm gonna adjust the average. Maybe do 4. Scan time is about a minute. Maybe we could increase the number of pixels. Maybe speed this up. So about 120, 4 scans. Let's see if the image looks better. Okay, so you can see this is a 5.7 times 63, so you can figure out how much that zooms. If you're interested in how big these samples are, you could also go to graphics tab here. There's a scale bar. Click on that, and then you can figure this about 5 microns. I don't know why the font is so small. There you go. So you can see the font here. You can also increase the thickness of that bar. All right, you can also change its color if you wish. Yeah. All right, so this is about 5 micron. Okay. If you don't like that object, you can also click and delete. Okay, so that's how you show how much you could zoom in. So that's for the 63. While we're at it, I'm going to rezoom back out, reset the zoom here, go live, so we see everything. We'll go over some Z stacking here. All right, so the other video goes over each of these things. I'll go over Z stacking. Click Z stack here. We can minimize the tab here, minimize the tab here. So then this is the Z stack that we're interested in here. I'll hit live. Right here, this blue is where we're currently at on the focus here. So I'm gonna adjust the Z. And then you'll notice when I adjust the Z, this moves up and down. All right. And we're trying to go where the signal disappears. So we're on the top. So this would be the top. I'll hit set last, and then I'll adjust the Z to go to the other position, and I'll go when there's no more signal, so we know that's the bottom of the sample. So it should be about here. Set first. Okay, and then you like to double check and go between those sections just to make sure we have some signal there. Okay, here then you could adjust. I'll let's turn off the live real quick. And when we're over here, we could adjust the number of slices you want. The optimal here is just based on what your thickness was before. So you got the channels actually. The channel is 1.6, so usually it's half of that. That's why we have the optimal 1.8 here. So sometimes it's fine to, you can click on that and see how many slices you could do, or you could always add more slices if you feel like you need to have more slices in there. So And then when you're ready, you'd hit here, start experiment. So I'll hit start experiment there. But over here, so right now it's 2000 by 2000. Maybe that's a little bit too much. So I'll go 1000 by 1000. The more optimized this is, when you do the Z-stack, it may take longer. Some people do just go to 512 by 512 since it's a little faster. I'm gonna do 1000 by 1000, increase the scan a little bit. Maybe don't do as many averages. So it'll be about there. Okay. Then I'll hit start experiment. And then it's gonna ask you to save the Z-stack. I'll go 9. Okay. Okay. And down here it says it's going to take about 28 minutes. Right. It's going to take too long for this demonstration, so I'm going to hit stop here. Okay, I'm going to switch this to 512 by 512 and increase the scan a little bit faster. Just for demonstration purposes, so we kind of see how this. I'm gonna lower the amount of slices, just so we kind of maybe just about 30. And hit start here. We'll override the other one. Overwrite the 9. Okay. Maybe it's open right here. Gotta close this first. Start. And save. Okay. So now it's slicing through or adjusting the Z height here and taking the pictures at each slice. Okay. I can also do split the colors. So we can see each of the colors at the slices. There's also a gallery view. So however many slices we picked, I believe 30. So there's 30 frames, and it's cutting through. It's moving the Z up a little bit as it's taking a picture at each frame. Right. The image quality could be better if we optimize the acquisition parameters more. But just for demonstration purposes, I'm just showing you. So as you can see down here, it takes about 1 minute, minute and a half. To take these 30 slices at a really quick scan speed. But if you want a better quality each of the slices, you can also slow it down. Right. Okay, so that's done. There's also a 3D view if you want to click here. It does a 3D rendering of the sample. So you kind of perceive what it looks like. Okay, so that's how you do a Z-stack. The other thing I'm going to show should be good. Okay. The other video will probably show the other techniques. Tile scan will probably be interesting. The video goes a pretty good job over that. Okay, so for now, let me show you the shutdown procedures. So let's go over here. So if you're the last user for the day, then you would click here and turn off. There's going to be another user after the session, so I'm going to turn this to standby. Okay. So everything would be off on standby for if someone's going to be using the instrument after you that day. If you're the last user of the day, then you just turn it off. Okay, so after here, I'm going to close this. You can say no to the images that you don't plan on saving. Right, and then we'll just close the software there. And it gives you a last asking you, making sure that you have it on standby and off for the other ones. Okay. Over here, once you're done there, if you were the last user, then you'd wait until you hear the Argon it's powered down, and then you would turn off the microscope. Since there is another user after me, I'm going to leave the microscope on, and I'm just going to remove my sample here. So I'm going to move this up here. Since this did have oil, so I'm going to make sure that I use the lens paper to wipe the objective, and also use lens solution here. I'm going to wear gloves for that part, so I'm going to get some gloves on. So I'm going to apply some lens solution on the paper here. I'm going to wipe the objective gently. Just to make sure we remove the oil. Also, I'm going to then just dry it off with the unwet portion there. Okay. Remove my sample. All right, I'm going to actually lower the stage. Hitting. Okay, grab the slide out. This solution here on the lens, I could also use lens solution here to wipe this out. Make sure it's clean. Okay. It's really important to remove the oil off of the objective because the oil does harden if you don't remove it. Okay. And then as a default, you want to switch back to the 10x as the default. Okay. If you're the last user, you cover the objectives, use the cover and cover it up there. Okay. And that's how we turn on the instrument and turn off the instrument there.